So now let's try to solve the question using the concept of relative motion. So when we consider relative motion, we'll have to individually consider relative velocity and relative acceleration. But before that, what is the advantage of using relative motion here? When we use relative velocity, it allows us to analyze the motion in a simpler way. How? By removing the need to think about multiple directions or multiple frames, to be more precise with respect to this question, or multiple cars. In this problem, we can calculate the distance traveled by the two cars. How? By treating their relative velocity and relative acceleration as one combined motion. This is really important. As one combined motion rather than solving for each car individually. So this is how we calculate the car motion individually, where we have car A and car B, velocity of car A being VA, acceleration being AA, velocity of B being VB and AB individually. Now when we analyze this as one combined motion, we have, instead of two cars, only one car AB. Instead of having two velocities VA and VB, we have one car moving with relative velocity VAB. Since both of these cars are moving in the opposite direction, we know that the relative velocity would be the sum of these two, which is VA plus VB. And one combined motion means, instead of having two different accelerations, we'll have one acceleration, which is the relative acceleration. Since again this acceleration, since both of the objects are moving in the opposite direction, acceleration would also add up, and therefore acceleration of AB would be AA plus AB. Okay, so we have two cars here. While we analyze the motion individually, while we analyze the motion in a combined motion, we have only one car with one relative velocity and with one acceleration. Now, visualization, as I say, is always important. If you can, just try to take down this solution along with me, and then as you as the number of problems goes higher, you'll be able to visualize this right from your mind. You don't need to draw it on a paper. But till then, till you reach such a point, I would recommend, I would suggest that you please make sure that you make a note of all these things. So now we have, okay, let me just write it down here as well so things become more clear. So this is two cars being analyzed individually, and here we have only one car which is being analyzed in relative motion. So what did we say? We have car A traveling with velocity VA, eventually coming to rest 0. We have car B coming with velocity VB, which will also come to rest, final velocity being 0, right? So both of these will have acceleration. Acceleration of A is equal to -2. Acceleration of B is equal to -2. And you can make two different equations out of these two constraints and then solve it individually. That is what we did in the previous section. Now in this section, what we will approach is using the relative motion. So instead of having car A and car B, we only have car AB. Instead of having VA and VB, we have only relative velocity VAB. Instead of having acceleration of A and acceleration of B individually, we only have one acceleration, which is acceleration of relative acceleration AB. Okay. Now, analyzing the relative motion separately, V square minus U square will be 2AS. Now, when this is the initial condition, this over here is the final condition. In the final condition, the velocity is 0. Why? Because both of the cars are at rest. So final is V square, which is 0 square. Initial is relative velocity VAB, which is the sum of Let me just write it down here. So relative velocity VAB is actually the sum of individual velocities of VA and VB, which is equal to 20 plus 20, which is equal to 40. And why is it VA plus VB? Because VA and VB are both moving in the opposite direction, and therefore the velocity will get added up. So we have VAB is equal to 40. So VAB square will be 40 square. Acceleration of AB, again, acceleration of AB, or which is actually relative acceleration, is the sum of two accelerations. And why is it the sum of two acceleration? Because the two objects are in the opposite direction, and therefore their velocities and their all relative aspects will get added up. So acceleration is -2 plus -2, which is equal to -4 meter per second square. And therefore, by equations of motion, we can say that 40 square, 1600, 4 into 2 is -8, minus and minus becomes positive, 1600 by 8 is 200, and therefore the separation is 200. Since the object has moved, since the combined motion of AB has moved a distance of 200 meters, already the distance was 300, which means the leftover distance would be, the leftover distance here would be 100 meters. Okay, the combined motion has already traveled for 200 meters, which means the balance distance to be covered is 100 meters. Okay, so that's it with solving the question using relative velocity. Moving on to the next one now.